is Commander Dead Michael, as usual,
Hello.
dealing with the technical side of things.
Yes.
And streaming as well, right?
Yes. Video stream just started. Also watching the chats, of course.
Great. I am Nightfall Zero, your host. I'm here streaming live from the Red Comet. And here with me in the cockpit is, as usual, our cosmologist, Commander Shoba.
Hello.
Hello. Sorry again, everyone. We were supposed to be live yesterday, but due to some real-life complications, we had to postpone this episode to today. I know that, Shoba, you're quite busy these days, right?
Yep, that's how science is. When something comes up, that's all you do.
Indeed. So sometimes things happen, and we have to adapt to it if we want to survive. But today we are here again, as expected, every week. And the topic of today is alien life. We've been asked for this.
Ooh.
We had quite a few requests, actually. The topic came up during previous episodes, despite being unrelated to the topic at hand. So we decided to dedicate an episode to it. We got quite a few questions, actually.
I will do my best, even though it's not what I work on.
Yeah, you're not an alienologist.
That's
right?
all way too small scale. Anything less big than a galaxy, I don't really care about.
Yeah, I think this episode...
Maybe black holes.
Well, no. What if the aliens are very big, though?
Then maybe.
I think
But
this
the
will be
size of
more
the
of a
galaxy.
discussion than you talking all the time. I think we will be discussing the topic itself more. Because, yeah, well, you're not actually... working on the field, but everyone has got huge interest in the topic, and I think if you can't answer a thing, we can speculate, and I hope I can do my part.
I will do my best.
Well, it is one of these things, because aliens is a big thing in sci-fi and, games and books and movies. It's one of the first things that people think when thinking about when seeing space and wondering what is out there. And the question, are we alone, is quite an obvious one of the first ones that pop up, one of the big questions, I dare say. I'm not sure if in actual science there is such a thing as an alienologist or something on that.
Yeah, we call it exobiology.
That sounds better, to be fair.
Yeah, it's like exoplanets, which means outside, but biology.
Okay, it sounds almost legit.
It is legit.
I actually thought it was xenobiology.
That's less of a thing. That would assume we have a zoology, which we don't.
That would be great, though, because when we actually find alien life, we go, "You Xenos, die for the Emperor!"
Exactly.
So that would be nice, but sadly, I guess scientists don't have.
Nice, but not wise.
They don't have sense of humor, so.
Well, it's
They
just
do.
way too niche, right? No one gets it.
That's the thing.
So let's start with a question from me before we actually delve into more in-depth questions for you. What is life? Now, this is not a philosophical question. I'm asking from the point of view of science. How do you define life? Because if you're looking for it, you need to know what you're looking for. So what is the threshold? Where do you draw the line from something that's not alive to something that's alive?
Well, that's a question we can ask even about Earth life, really. Is a microbe alive? Is a mosquito alive? Somewhere in between, there's a limit. So it's something that zoologists have to deal with even locally. But usually the definition of life is something that is self-sustainable and reproduces itself. So increases its numbers even when it's left alone in the environment.
Right.
Although that's not the entire answer, because of course, say you start a chain reaction of chemistry, for example, you set fire to something, the fire will spread, but it doesn't mean the fire is alive. Even though it's reproducing itself and increasing its area, we wouldn't call it life. So usually people add a a constraint of complexity, so that life has to be sufficiently complex, but that's very subjective in a way.
So you're telling me there is no official definition of life?
There is no body that defines definitions. It's whatever is useful for the thing you're thinking about.
So if you're looking for it outside of our planet, how could you state that you found life if there is no definition for it?
I guess it will have to be clear enough that most people would agree, like many definitions are. Ultimately, you use a word in a way that everyone agrees what it is.
I'm surprised, though. I mean, I would expect at least biologists on Earth to have a clear idea about what life is.
Not really. Some things are pretty ambiguous, like a virus. A virus behaves in a completely mechanical way, a bit like a nanobot. So it just does always the same thing, always interacts with cells in the same way. It's entirely predictable. Doesn't seem to have much decision-making to do. So it's not considered to be alive by some biologists. There is an awkward middle.
Okay.
But I guess when we talk about other planets, we really mean microbial life. Life that can form maybe colonies, life that can move. Mobility is sometimes a requirement for animal life as opposed to plants that don't move. So the ability to form colonies or the ability to move would be one criterion.
Okay. Well, of course, I mean, you're a cosmologist. For anyone who is listening who still don't know who Commander Shoba is, she's a professional cosmologist working at UCL, and her area of expertise is distant quasars. We spoke about the early universe last week, and quasars as well. So if you missed that episode and you want to hear about exactly what our Commander Shoba does every day for a living, you can just go back and listen to previous episodes. So I'm not sure about, I mean, as a cosmologist, you don't really deal with this topic much, right?
It comes up in the context of exoplanets. Cosmology is really the story of the study of the history of the universe. So we'd like to know things like when could the first exoplanets be formed? When could you first have habitable planets? When was there enough water around in the universe? Really, when could life start? That could be a cosmological question. Defining cosmology as a history on a universal scale, really. So in a sense, we do worry about it sometimes. We're excited when we find very ancient traces of the first elements that make life, like carbon and nitrogen that we're used to on
Well,
Earth.
those are kind of everywhere, though, right?
Yeah, but not arbitrarily early. So if you go very far back in the universe, look at very distant objects, they didn't contain nearly as much as we have today, and there was a time where you didn't have enough of it to make a planet, that's for sure.
Okay. Well, setting aside then the fact that we can't really give a clear definition of life, let's go with, something that can be reasonably agreed on that is life. And you went with your definition, which I believe is one that biologists like Professor Richard Dawkins says that their life is replicators. Like I believe that she classifies life as replicators.
Yes.
Organisms able to reproduce themselves without necessarily any external input forcing them to do so, right?
Yeah.
So going by that definition, let's see if we can, speculate a bit about where could it be, when could it happen, and if it can exist at the moment. As I said before, we got a few questions. If you guys are listening, feel free to drop questions in the astronomy channel on FleetCom Discord server, or in the Distant Radio Discord server in the Dangerous Cosmology channel. We are monitoring those channels as we speak. So every question will be answered live. And of course, Twitch as well.
Yeah, and YouTube too.
Right? And YouTube. We are pretty much everywhere.
Yeah. Except Facebook, because we don't do Facebook.
Yeah, I was literally going to say that.
Yeah.
So yeah, no Facebook, no Instagram, no those things.
No WhatsApp.
We're serious. Yeah, no WhatsApp.
We're not
Live
that
streams
young.
are possible. Yeah, exactly.
Yeah, we're too old for WhatsApp, right? Yeah.
Well, we
Or
use
Instagram.
Discord. It's literally the youngest of all those services. So
No, I don't
Yeah.
agree. I think Discord is the spiritual descendant of IRC.
yeah, but
Mumble.
it's the youngest as it's
Yeah,
it
but
goes for voice chat, live
it's
streaming, and stuff like that.
it's spiritually old.
Yeah,
Okay,
I'm also an IRC veteran, so I agree.
indeed, we're old guys, so we appreciate Discord
Yes.
with the bare bones gray background. Yeah.
Yeah.
Anyway, so
We were digressing.
let us. Yeah, I mean, yeah, sometimes we do. But hey, let's go on. Let's start with the questions because, as said, we have quite a few. Let's see. We have the first one was from you, actually.
Yeah,
Michael.
pretty general.
So, do you want to ask them?
Yeah, well, those are the pretty basic questions in about alien life, of course. First question was, are we alone? And the second one was, if not, why haven't we met anyone yet? And those two questions actually make up the base of the Fermi paradox as we know it.
Indeed, which is
Pretty much.
a very common thing that people bring up, the Fermi paradox. Can you explain what it is and potential solutions to it, Shobo?
Roughly speaking, the Fermi paradox is if life is possible in the universe, it shouldn't be so rare. So where are all the aliens? Why have we not seen them yet?
Right, because life is supposed to be common, right? At least carbon-based life, as far as we know, is made of very common materials that are found everywhere in the universe. We are not rare.
The building blocks are not rare. Exactly how rare planets that can support life are is very much unknown still. We haven't found a single planet for which we are sure it is habitable. So we have a whole bunch of candidates. We have a lot of planets that are the correct temperature, distance from the star, what we call the habitable zone. We have about 20 of them that are Earth-like at the right distance to have water if they have it. And we know some planets that have water in their atmospheres, but those are not the same. So we have never had a confirmed case of an exoplanet that is roughly Earth-size with water around it.
But it doesn't have to be two, right? I mean, life doesn't have to be us. It could take other forms and adapt to other sort of planets. It doesn't have to be exactly like Earth.
That's true, but we have to start with the type of life that we know, which is water-based. So the first question would be, how common is liquid water on a surface? And currently, we don't have proof of any, apart from the Earth. We are not at that level yet. So it is still too early to say how many planets even have liquid water, let alone how many having liquid water would have life like us, and how long it would take to develop.
And water is necessary? Absolutely necessary?
Well, maybe not, but we have to start with what we know, because the rest is even more unknown, right?
Yeah,
so it has been suggested you can have life based on methane or arsenic or silicates, a whole bunch of things, but those are even more unknown because we don't even have the Earth as a reference. At least for the Earth, we know at this temperature plus liquid water, life is possible. So we start with that.
Yeah, it's also kind of useless asking if there's life that we can't actually see or distinguish from the surroundings. Because, yeah, we can't. If you can't see them, it makes no use thinking about it, I think. So we should start with things that actually relate somehow to our life.
Okay.
Sorry if that.
So you're saying that. No, I understand. I'm just thinking that maybe that restricts a bit our field of search. Because maybe water-based life is rare.
Oh, but we're not restricted to that. Exobiologists like looking at the atmospheres of any planet they can get their hands on. It's not like we're exploring the atmospheres of only one type. There could be markers of life in very unexpected places. For example, if we saw a large amount of methane in a gas giant, we could say that methane is a very common product of life, as we know it on Earth. So if this planet has the correct signature, it could have it. It's not like we're not looking. We're really looking at any atmospheres we can find, period. Because it's not that easy to do yet. We don't know many atmospheres. We don't know many cases.
Right. Okay, so one possible solution, quote unquote, of the Fermi paradox is just by saying that the premise is not valid, in the sense that we don't know how common it actually is. So the paradox could not be a paradox after all.
There's many explanations for the Fermi paradox. It's called that. I think it's a technicality. It's not really a paradox. It has many possible explanations.
But no clear answer.
Okay.
I think one of the questions was, what is my favorite explanation?
Yeah, I think that comes afterwards, and we can keep going. The next question is from Scaleus, who I believe is listening to us. He was quite excited about today's talk, and his question, quite articulate, is, well, the premise is that indeed, for life to form on a planet, certain conditions have to be met, like we just mentioned, the Goldilocks zone, having water, protection from radiation, etc. But not all planets meeting those conditions do have life.
Well, we don't know any planets meeting those criteria.
Okay, that answered the first part of his question, I guess. So you're saying that we have no confirmation at all of any planets being in a Goldilocks zone with water and without deadly radiation.
So, as I said, we know about 20 planets that are Earth-like in the Goldilocks zone. Out of these, I think 3 of them have suspicious densities that would indicate they contain at least some water, because they're not heavy enough to be entirely made of rock. So if you just take their mass and you take their sizes, and you try to say how dense they are less dense than the Earth, so it's a bit suspicious that they might have a lot of water on them. But to confirm that, we need to actually look at the composition of the atmosphere, and we haven't done that for any of these terrestrial planets yet, because looking at atmospheres is really the frontier of what astronomy can do currently. There's very few cases, and we can only do it for very big planets, or planets very close to their star. So there's no confirmation of water on any terrestrial-like planet yet.
Okay.
Only some suspicions, but no proof. And even so, there's only 20 that would be at the right in the Goldilocks zone at all.
Yeah, because Calais was going on with this question, saying that assuming that all worlds similar to Earth should have life, assuming that we're not just failing to detect it. I mean, let's like assume that somewhere a planet like Earth, like exactly like Earth in terms of environmental conditions, etc., exists.
Right. Could we see it?
No, the question is, would life on such a planet be inevitable?
We have no idea. I mean, the thing is, if you look at the timeline of life on Earth, after the formation of the Earth, it only took about 200 million years for water to arrive. After that, it only takes about 400 million years for life to start. It's a very short interval between formation, water, and life. Very quick succession. But even after life starts, that life has only been able to send radio signals for like an infinitesimal fraction of the time it's been on Earth. Only the last few hundred years at the scale of 4 billion years. The development of life on Earth being able to emit detectable signals is an extremely recent development. It's almost like going from water to life is a much easier and fast step than going from boring life to evolved life. Evolution seems like it's much more unlikely than getting life from water. If you just look at the time scale it took. So yeah. Life could be out there, but it would be boring life. And can we even detect life at that level? That if it doesn't emit any radio signals, if it doesn't emit any broad scale.
Yeah, no, of course.
Things.
In general, when people ask this question, are we alone? They usually mean, aliens in the sense creatures at least as evolved as we are. In many cases, they think of even more evolved than us. If you tell them, yeah, aliens exist, they're just microbes, they probably wouldn't be as impressed as if you said, yeah, they have spaceship and stuff.
Yeah, and in a way, if they emit lots of radio waves, it would also be easier to detect because we're listening in on a lot of these potential habitable exoplanets.
And maybe the Fermi paradox is kind of like that. If life is common, there should have been evolved enough by now around us to detect radio from them, and we don't.
But if you look at the example of Earth, evolution into a complex life is a much more unlikely event than just life itself.
Yeah,
it's exceedingly slow and rare. If it's taken so many billions of years to evolve a civilization compared to just having life.
Yeah, that's
so there's
right.
Yes. How rare is evolution? I think that's the main bottleneck, if there is one.
But even if it's not rare, it may be extremely common. It's just that it hasn't reached us yet. In terms of we can't see it because radio is just too slow and too young to be seen.
Well, if a planet is at 1,000 light years, it would take 1,000 years for the radio emission to reach us.
Exactly. And we've been sending, as Earth, radio signals for how many years? 60? How much? How many?
Less than 100, right? Maybe a bit more. I'm not sure. When was radio invented?
I'm not sure.
Radio itself, the technology was invented around a little more than 100 years ago. But the actual, what's it called? The public use started around the 30s, I think.
So yeah, the first radio antenna was 1890. So a bit more than 100 years.
Yeah, so that's clearly not enough to reach 1,000 light years away.
Absolutely not.
So maybe our descendants, hundreds of years from now, will be suddenly assaulted by a lot of radio waves from everywhere as we are hit by all the other planets around us.
Right,
suddenly.
but the question is, if those planets that we see that look habitable, if they had been sending signals to us for 1,000 years, they would have reached us by now. So they haven't been sending us radio signals for 1,000 years.
I'm talking about... So we can safely say that those exoplanets do not manifest life advanced enough to send radio signals.
Or they don't want to. I mean, you never know.
Yeah.
They haven't sent them. We haven't seen radio signals from them.
So you say that they may be even more advanced than us, but they're not watching TV.
Maybe they just don't want to,
more advanced, but yeah, there's a popular theory going around. It's called the dark forest theory, which assumes everyone's a hunter stalking through a dark forest and therefore trying their best to hide themselves.
Because they see what happens to the others, the idiots.
So we're fucked.
Exactly. Yeah, because we don't detect any life that actually makes themselves known.
Oh wait, well this makes sense. Basically, the galaxy is full of reapers.
Yes.
And as soon as they see someone, they just eat it.
Well, they come from outside the galaxy and just monitor it from.
So everyone is being silent, like hush, don't shout, don't be loud. Look at those idiots from Earth; they don't know what's coming.
Wait,
let's watch the show.
We've been only reaching out 100 light years or so until now. Further, our signals couldn't reach yet.
Or they might just be a lot more efficient than us with their technology, right? Because we were emitting radio waves into space by accident when we first started broadcasting radio channels, like this one that we're currently talking on.
Hello, space.
But actually now, with more efficient antennae and stuff, we're broadcasting less into space than we used to. So we become more silent due to efficiency. So that's possible too. Maybe they're just too efficient and they don't really care about finding civilizations out there.
Yes.
Who knows?
So basically all their radio has passed us by now. That's what you're saying. We are too late to see it.
Yes, and they're not actively reaching out.
Not anymore. Okay. Well, I guess you can't
Yeah, or they got
completely rule
killed
that out, but
by Reapers. And that's why they are not
I
reaching
guess.
out anymore.
Sorry, I'm not sure if you can answer this question. Vertical blank. I'm taking this question now before we go into other topics, but he asked this question before. I think this is more a biology question because he's asking if you were talking about the jump from prokaryotic to eukaryotic cells. I have no idea what that means.
Not even. So I was just talking about the fraction of time we've been emitting radio to a level that's detectable. So that's a very short time, about 150 years at the scale of 4 billion that life has been around. It's a tiny number. At what point would life be detectable is the other question. If it was just bacteria, what would you see? If you were looking at the atmosphere of a planet with bacteria from far away, or even dinosaurs on it, you couldn't actually see the dinosaurs, of course. You'd have to see the effects that they're having on the atmosphere and the environment. But humans have modified the surface of the planet way more than even dinosaurs ever did. We have built cities on much larger scales.
Yeah, that is clear enough.
That's very recent.
Yeah, that is clear enough, especially lately. I think everyone is seeing the effects of our presence on this planet just by looking at the atmosphere, I guess.
Yes, so that might be a detectable signal. If it was just mammals on the surface, could we even tell the difference? For example, animals produce a lot of methane. It's a very common product of life on Earth, but some volcanoes produce it too. So if we saw methane on an Earth-like planet, could we immediately know it's life for sure? I mean, where's the line? We haven't really had to think about it because we're so far from that point. But it's a valid question. What even is detectable?
Right. Well, we got actually a few questions from Nagi. I'm not sure if he's listening, but I believe that some of the questions may have been answered already as we were talking right now. He's asking, well, why is it so difficult to find planets suitable for life? I'm not sure if that, I mean, I would answer just with because it is. I mean, are Earth-like worlds rare as far as we know?
Not really. I mean, when we started looking for exoplanets, the first things we saw were the easiest to find. So they were massive planets very close to their stars.
Gas giants are
gas
not
giants.
Close. They're not close to the star,
They're
usually.
called hot Jupiters. So they're a specific type of gas giant that's also very close to their star.
Ah, I see.
Because they were the easiest to see, they were also the first ones we saw. And we were kind of surprised because we didn't know they existed.
Okay.
But obviously they're the easiest to find because every time they pass in front of their star, they block out a lot of light. So you see the light from the star dipping regularly is a very clear signal. So they're the easiest to find, so we found them at first. Then as we got better and we became able to see terrestrial-like planets, we actually found quite a few. They're not that rare, but they are harder to find.
Yeah, we're talking about, like, I'm not sure about Elite, if all Earth-like worlds are in the Goldilocks. I assume they are because there is liquid water, there is vegetation. And, I mean, Earth-like worlds in Elite are quite rare.
Yes.
Compared to icy bodies, metal-rich bodies, gas giants even. For what we know currently, is it true in our universe as well? Are they that rare compared to other kinds of planets?
No, maybe not that rare, but we don't know yet because they are harder to find. So we don't know how many we're missing as well. So for hot Jupiters, we're not missing many because they're easy. But if it's a very small signal, you have to be quite lucky to see it.
It's not as simple as pointing at a star and scanning like we do in Elite, and you see everything, and you can easily see, oh, okay, we clear out this system. We know everything that's on it. Our cat is destroying the house. Sorry for the noise. Yeah, he just... Never mind. So I was saying, it's not as easy as to just honk the system and suddenly you know everything that's in it. You need to look for specific things and you may just not see them even if they're there.
Basically, we monitor the star's brightness, and if it dips, it means something has passed in front of it between the star and us. And if it happens regularly enough, it's probably a planet. Then we can look in detail.
Yeah, but what if the orbit is perpendicular to you?
Then we have no way of seeing it.
Yeah, that's what I meant. I mean,
that's the answer.
like, I don't know, Alpha Centauri may have like 100 Earth-like planets and we don't know about it.
But we think they'll be aligned. There's good reason to believe planets are aligned. And Proxima Centauri b does have planets.
Sorry.
Okay, so...
I need to do
Sorry,
something real quick, because I forgot this.
You need to go to the toilet? What?
Now recording.
This.
Oh, you haven't been recording.
Yeah, well, I've been recording YouTube, so we can
okay.
grab the audio from there. No problem.
Fair enough.
Fine,
But
okay.
this is better audio.
No problem.
I did think something was missing, but I couldn't pinpoint what. So, anyway, yeah, but like, if we see a star with no planets, it could just be that the orbital line is not visible to us.
Yep.
But it may be full of planets.
Yep. Well, we have, I think, one or two other ways, if we're lucky, that we can find them anyway, but that's much, much harder. Looking at dips in the light is by far the most successful and common technique.
Okay.
Sadly, it's not perfect.
Yeah, so as mentioned, it's not as easy as just honking the planet and we suddenly discover anything that's in it. We're not there yet.
Well, I mean, we do get the James Webb Telescope, which might increase resolution and stuff like that, but this will mainly be used to look further back in time. But it
will be very useful for planets, though.
Yeah, will it be used for that?
Yeah, for sure.
Oh,
so
great.
One thing we're able to do now is look at atmospheres, and for atmospheres, you need to take a spectrum of the light, divide the light in all its component colors, and currently we can only do that efficiently for visible light. With the James Webb, we'll be able to do that for infrared light too, properly.
I'm looking forward to
currently, it's very, very difficult.
Yeah, I know Selfish By. I'm reading Selfish By in the chat, and he's saying he's missing because he is apparently working on his physics investigation. Yeah, well, you're still listening to us and typing in the chat, so it doesn't seem like you're working hard. I mean, if you have a deadline, I think you should focus on that.
Oh no, I listen to things in the background when I work. I get you.
Yeah, well, I guess science is a problem for a lot of people nowadays, lots of deadlines, huh? But hey, we don't want you to distract yourself from your job, so, you know. But we're happy to know that at least you're listening, even if you're not participating actively, but... Sorry for interrupting you, I just wanted to call out Selfish By. Because he can't answer back, so I can trash talk him, and yeah, he can't answer back, not on audio at least. Indeed. So yeah, the bottom line is that we can't really draw numbers on how likely it is because we don't know how common Earth-like worlds are.
We don't even know how common liquid water is.
Okay, so there are just too many things we don't know.
Pretty much. But
we will know soon. There's a few specific experiments aimed at finding exoplanets and imaging them directly, actually taking pictures of them around other stars.
Someone on YouTube is asking an interesting question. I'm gonna interject this real quick, and it's because it's about the radio signals. What are your thoughts on the WOW signal? That is it a natural phenomenon, or was it possibly something intelligent?
Sorry, the what?
It could be. Signal. Well, the WOW signal was the most complex radio signal we've received during the search for extraterrestrial life.
I am ashamed I never heard of it.
No.
It's because the scientist was monitoring when it was. They circled it and they wrote "Wow!" exclamation mark next to it.
Oh, it's not that they were playing Warcraft now.
No.
Okay.
Aliens play Warcraft. Breaking news.
It was Commander Popper Beans who
Maybe it's
asked
the
question.
Burning Legion.
Shout out.
How do you know? They're coming for us. So what about it?
It never repeated. So it was the most complex signal we got. It was very strange. It started off very loud and it decreased. Usually you just get random static if you point your radio dish towards a random star. And this was the most complicated signal we got. Lots of things happening in it. But it never repeated. And we've been monitoring the same star for a while now. There was nothing similar again. So it's hard to say. Usually in communications and in conversations, you need some sort of baseline, some sort of repeating pattern in any sort of language. Well, this thing only happened once. It was a weird signal, but in my opinion, not intelligent.
So basically a coincidence. It just sounded something that could be artificial, but it wasn't.
It was pretty special. It was not just static. There was something emitting radio. It just didn't sound like something intelligent emitting radio. So maybe a star outburst or a collision of magnetic fields that can accelerate particles and emit radio waves. There are natural ways to generate radio. It was definitely a radio-emitting event. Then the question is, where do you draw the line at communication? So certainly when we broadcast into space messages in the hope of being heard, we try to give them a structure, a repeating pattern, repeat them on a loop and broadcast them everywhere. If it was trying to communicate with us, it was doing it very poorly.
Well, when was the signal received?
I'm not sure. It was in the 70s.
In the 70s, yeah. Well, maybe it was the first try of some not so far developed civilization with anything that emits radio waves. Maybe they did. Maybe they invented nuclear fission earlier than radio. So we don't know.
Nuclear fishing? What did you say?
Fission.
Yeah.
Okay.
Fishing.
Like, what the fuck? You're fishing with bombs? Are they Americans? I don't know.
That's a thing.
Nuclear bombs.
I'm sure it is. Dynamite fishing is a
No,
thing.
nuclear bombs.
Yeah. Yeah. Dynamite fishing is a
Yeah,
thing.
well.
Just tiny nukes, you know?
Yeah,
we fly
sure.
in, harvest whole water planets for their water life with one.
Maybe
What
in
the
Texas.
planets.
But anyway, no. Okay, so what if it is repeating just at a very long interval?
Well, maybe. All I'll say is if they're trying to establish communication, they're doing it quite poorly.
Well, I don't know. I mean, maybe I am completely misguided, but what if... I mean, if it is very far away, okay?
I don't think it was deliberate.
No, okay, fine. But assuming that a signal is sent from somewhere, it will get redshifted, right?
If it's from another galaxy far away.
So it will get redshifted, which means it will get stretched in how you will hear it in slow motion.
No, I have to stop you. We are so far from detecting radio emissions from planets in other galaxies. It is so far in the sci-fi realm that it's completely impossible currently. Other galaxies in the Milky Way are completely impossible. I mean, even if you take the Earth and you copy-paste it 2,000 light years away, we wouldn't even be able to see that with our current instruments. Like the literal Earth, 2,000 light years away, we wouldn't notice.
But we still detect light from the CMB.
Light, yes.
Well, radio is technically light.
It's not, on the scale of a planet, it's just not loud enough.
What if someone is sending signals using light?
They would need to harvest something like the big fraction of the energy of a star to send a signal at that power from another galaxy.
Oof.
Well, you can't rule that out.
Sure, we can't rule it out. I mean, we're monitoring everything.
So we can't really say where it came from.
Sometimes we look specifically at planets with likely Earth-like planets around them, but there's also searchers that just look over the entire sky for radio signals. Just in case we see something repeating or something a
Well,
bit
we do
suspicious.
see repeating patterns in like pulsars, for example.
Yeah, you know.
And
yeah.
how can we rule out that these are not actual artificial signals?
And for pulsars, look at other types of light too. So it's not only radio; it's flashing all types of the entire electromagnetic spectrum.
Yeah, no, I'm not
And
talking
again,
about
if
radio.
we're trying to emit something at the power of a pulsar, you need to harness the power of a star to do it. It's that scale of energy. It's not something you'd get from a civilization like the Earth.
No, but if it's a Type 3 civilization, try to contact other galaxies because they mastered already their own.
Then all they would have to do is broadcast something like 1, 1, 2, 1, 2, 3, 1, 1, 2, 1, 2, 3.
Well, maybe they're not that smart.
Right, they're Type 3, but they don't know that the repeating pattern is noticeable.
Well, maybe they're intelligent in other ways. I don't know.
Everyone's special.
I mean,
So
maybe they don't have numbers.
Yeah, they don't do numbers. They do technology, but not numbers.
Maybe they solve the galaxy without using math.
Sure.
How do
But
you
how
know?
can you have technology at that scale and know like basic numeracy skills?
No, they have no numbers. They don't count.
Maybe
Sure,
it's-
that's a good question.
it
What
developed
type
on
of
an-
intelligence?
It developed on a cellular base, so they
Hey,
don't
I'm
know about their radioactive existence.
I'm just giving you ideas, okay?
No, it's true, but it's like, how would we know? Obviously, what we have to look for is a pattern that shows structure.
Yeah.
And that's roughly the right energy.
Yeah, that's why I said the wow signal probably wasn't deliberate, but more of an accident of someone, if it came from an intelligent species, of course. Maybe it.
Oh fuck! We just contacted someone else. Stop it! Stop doing that!
Not even that. Maybe,
Hide!
maybe
Hide!
They experimented with
Turn your music down.
some technology, but the EM waves were just a byproduct of it. You know?
Yeah.
And they didn't even know that happened, and that's why it never happened again. It maybe was just an experiment that failed.
Sure.
Yeah, I mean, at this point, every hypothesis could be real.
Yeah, it could
So
be.
going
the fun
back,
thing is speculating about it.
yeah, no, obviously, but
My favorite explanation is, some kid got a hold of their broadcasting, and they were like, "Yeah, I'm gonna broadcast my music into space." And then the parents came, and they're like, "Oh shit, turn it down, they'll hear you."
Yeah, but
that's a very convoluted explanation.
But at this point,
it would have had to be caught pretty quickly because the signal was so short.
about a minute, no?
Oh, about a minute? Oh, I'm sorry.
Yeah, pretty much about a minute, I think.
Awesome.
It wasn't repeating or anything. It was just a signal.
Maybe it was distant radio, 305. Maybe it was an ad.
Broadcasting for a total of 1 minute and then never again.
Well, yeah, I mean, it was a mistake of that Michael broadcasting too loud, and
Yeah,
just
that was that was me setting up the antenna array.
one of
Yes, exactly.
your famous technical issues.
Oh, it was a feedback loop.
All right.
You don't want to.
Exactly, it's a feedback loop. You know, when the microphone fucks up. And
All right, we've got that.
quick,
solved.
stop it! Anyway, yeah. So talking
Anyway.
about the Fermi paradox, and you were right. There was a question about this. What solution do you like the most, and you hope to actually be true? This is from Hoyer M.
Well, it's a personal preference.
Yeah, I mean, in your case, which one do you like?
But looking at how extreme the history of the universe has been, and how quickly life appeared on Earth, or after we got water, we could be the first, It's not that much of a stretch. Maybe we really are the ancient race of the Milky Way.
The Milky Way is fucked.
So we've got to prepare every race coming after us for the Reapers. Oh god, that's
Everyone is dead.
We will become the Reapers.
Oh yeah.
I mean,
I'd like that.
if we are supposed to be the wisest, I'm not sure that we will do our job properly.
So, for example, at the center of the Milky Way, we know there's Sage star, and Sage star is a supermassive black hole. And supermassive black holes sometimes have quasar episodes when they're eating too much and they emit a whole bunch of gamma rays and X-rays and so on. Well, there is a pretty convincing theory based on the past pattern of Sage star that when it was on, it actually sterilized all of the central, like, 10,000 light years of the Milky Way. And that's also where the oldest stars are. So even if life appeared way back when most of the stars of the Milky Way were made, most of the old stars are also in the center, and in the center you are susceptible to being killed off by the quasar phase of Sage star. So maybe life would only evolve and have enough time to evolve back in the suburbs where the sun is. And back in the suburbs where we are, it takes a lot more time to enrich the interstellar medium to have enough metals and carbon and silicon in it to make planets like the Earth. So it takes longer, and then evolution is a very rare event.
So life can only be recent.
Well, I'm saying it could be. It's one explanation. And after we found out this thing about the quasars killing off the centers of galaxies, it's more plausible. Of course, the oldest stars are in the center, but the center also gets killed off.
So we could be the elder race.
It could be. It's not that much of a stretch.
Yeah, that was going to be one of my questions, and it's good that we arrived to it naturally, because in sci-fi we often see us meeting aliens that are somehow advanced. They may be aggressive, they may be peaceful, but they're rarely less evolved than us, or even equal was. There's been a couple of movies that dealt with the idea that we could be actually more advanced than aliens. I believe it was one of my favorite I've seen in the recent years.
Let me guess. It involves killing insects.
No, it's not Starship Troopers.
Oh.
Come on.
Starship Troopers are more advanced than the fucking insects.
Well, not technologically.
Well, kind of.
No, they don't have weapons. They're just animals.
Exactly, so we're more advanced than them. They're just animals.
Yeah, okay, fine, but...
And we kill them anyway, because we're such good guys.
Yeah, no, I was not talking about Starship Troopers. I was talking about, I think it's District 13 or District 9? District 9. District 9, yeah. Where aliens actually arrive on Earth, but they're refugees.
Well, they're more advanced than us. They can travel through space.
Yeah, but not really, because they arrive and they're basically immigrants, and they're tribalistic. They're depicted as literal immigrants.
No, that was not the point of District 9. They only behave that way because we put them in camps. They had a technical fault. No one bothered talking to them about fixing the technical fault, and we all put them in camps.
What what I'm saying is that usually the idea of aliens is, they're technologically advanced. They arrive, they have lasers, blasters, plasma destroyers, and stuff like that. While in that case, they weren't really so on another level that they could just wipe us out completely. Yeah. So it created a political scenario which
more realistic, I guess.
Which we don't usually see, because in general we assume that aliens, just by the fact of arriving here, they're supposed to be more advanced.
Yeah.
But I don't think we had many. Well, maybe because it wouldn't be very interesting to write a book about us being the best, because
some universes have all races being equal, and they're in the far future. The Ian Banks novels are almost there. Civilizations don't live for long, so the human culture is at the same level as everyone else, and they all kind of settle at the same time, and that kind of thing.
But still, I mean, even in a real life scenario, it is quite interesting to think that we may be the most evolved form of life in the universe.
I didn't say the universe, but the Milky Way at least.
No, but it could very well be the universe. You can't really...
You can't disprove it. That's probably a bit more of a stretch.
Yeah.
But it is a stretch, of course. Well, okay, let's restrict this to the galaxy then, which is still quite a big thing.
Indeed.
We could be at the moment the only species evolved enough to
would put on us.
Time to start building mass relays.
I think most people wouldn't give a shit.
Yeah, most people. We are not
considering considering we don't give a shit how we treat our planet, I don't think we care about how we treat the galaxy. That's just my guess.
That's another explanation to the Fermi paradox. Even when civilizations eventually reach that point, they auto-destruct way too fast. So we don't see them because...
which is also something that I'm worried about. Because, yeah, that is one another solution, right? We don't see life because life kills itself.
Yeah.
Eventually.
When it gets to the technological point of broadcasting, it doesn't live for long. That's a depressing answer.
Yeah.
Well,
also one of the most scary things scientists are expecting is actually finding remnants of life rather close to us, because that would mean we still have.
Well, Mars is a candidate, right?
Not for a past civilization.
Well, Mars had water.
Mars had water. It did not have a civilization.
Well, we don't know. We haven't. Maybe it's underground.
We don't know.
It wouldn't erase the entire surface because Mars doesn't have volcanism. The tectonic plates don't move, so features on the surface don't get recycled in the same way as the Earth's crust. There's also less wind.
Maybe maybe they're Martian dwarves. They were always underground.
Okay, I don't know. Maybe there's no evidence of that.
Aha, I got you. Yeah, I mean, maybe. We are digging Mars now. Maybe we will break into a dwarven vault.
Right.
A dwarf?
Well, you don't know.
Sure. I mean, there's no evidence of that though.
Yet. But no, the thing is, I've read about this because I think that. I mean, I'm really not a scientist, not a biologist. I'm really just an idiot, so I may be talking out of my ass. But if I remember correctly, I read articles saying that complex life, oxygen-based life, is bound to pollute the atmosphere because we are hardwired to produce CO2 and consume oxygen, which naturally kills the atmosphere of a planet like ours, and then just basically ruins everything, because oxygen is by itself is poisonous. We are just adapted to it, but the fact that we consume it and produce CO2 is something we can't avoid. As beings, right. That's what we do.
But plant life does the opposite. So
yeah, but plants. I'm talking about humans here.
No, but it's not to say that life in general will prefer going one way over the other, turning oxygen into CO2 or CO2 into oxygen.
No. Again,
because both we know are possible.
I'm talking about humans, not life.
Yeah, humans. Humans have chosen one direction.
Humans or any other species that consumes oxygen to create CO2 is technically bound to fail unless they put some measures in place to limit the problem. But if left unchecked, this is a destructive process.
I'm not sure I believe that.
Well, again, I may be completely wrong or remembering what I read.
I would debate that. I'm not sure that's correct.
Sorry for that.
I don't think it's necessarily destructive. Turning oxygen into CO2 is an oxidization process. You take the carbon in your body, and every time you breathe, you basically lose a bit of mass. Some of the carbon you're made of gets bound to the oxygen, and you breathe it out. So you lose a bit of weight every time you breathe.
Great. So if you want to lose weight, breathe harder.
Well, kinda.
Great. So forget the gym, forget dieting, just breathe harder.
That's what you do at the gym.
Yeah, but you don't have to go at the gym to do that. You're just sitting at your PC playing Elite. Just breathe very loudly.
If you want to increase your metabolism, you'd have to do something like working out.
Yeah, it makes you breathe more.
Yeah, but I can breathe more without working out.
You can, yeah, but you don't use the oxygen then. You just...
Of course I do.
You'd use less of it.
You just circulate the air.
Well, you still use the oxygen.
No, the oxygen carries out the things that your cells don't need. So if you're at rest, you'll have less things to evacuate anyway. But it means the best way of losing weight is to not eat. There you go. Physics has solved the problem of dieting. Eat less.
Okay, well, that is a revolutionary discovery.
Concept, I know.
You heard it
With this
first.
one easy trick: eat less.
You heard it first on Dangerous Cosmology. If you want to
No wonder
lose
diet.
weight, stop eating. That's could win a Nobel for that. Anyway,
Any
sorry.
hints on how to gain weight, like breathing backwards?
Breathe less
You
at this
eat.
point. Just stop breathing, and you should get fat following this logic.
Well, no, you don't absorb carbon. Humans never absorb carbon from the air.
See, science is inconsistent.
I want to do
You
that.
can't do that.
I want to do photosynthesis. Synthesis. Sorry.
You could try. Let's do a live experiment. Michael, you can stop breathing for a bit.
Yeah,
Let's see
and
what
I
happens.
instantly develop chlorophyll to absorb the light.
If you get fat, the science is real.
Yeah.
We
How
don't
long
absorb
should
mass
the
from the
experiment
air.
last?
Anyway,
Yeah.
we're
digressing
talking
once
about
more.
Yeah, I am the master.
The
I am the master of
destructiveness.
digressing into stupid shit. That's my role in this show.
it was a
That's
good
fun.
question. It was the destructiveness of turning oxygen into CO2. It is a very destructive process because oxidization, where you add carbon onto oxygen onto stuff, is one of the most efficient and most high energy processes that chemistry has. I think it's a great way of gaining energy. You just waste oxygen, but it's not the only way. So how common is it as a way of gaining energy? We don't know. Obviously, photosynthesis is also possible. So which one evolves more often? We don't know.
It doesn't.
Okay.
Yeah. Okay. I don't want to go any deeper into that part.
No, we have a question from Kankravandas. He is asking in radio chatter, going against the rules. So I should chastise him because he should ask questions in the proper channel.
Yeah.
But since he is kind to us by spamming our advertisement every week in the Fitcom channel, I'm going to ask his question anyway. Hopefully he is still listening to us. He has two questions, actually. He is asking if we talked about non-carbon based life. We just briefly touched into it. He's asking that given the fact that carbon is way more common than ammonia, for example, can we assume that most, if not all, life would be carbon-based? And if not, what else can be life made of? Yeah, we mentioned this briefly, but...
There's a few things that have been proposed. Ammonia is one. Arsenic-based life should be possible.
Isn't that the
and
movie Evolution that's covering that? Arsenic-based life? I don't know if it's...
I don't know, but I think we discovered the bacteria on Earth that almost makes it work. Almost. So it should be at least theoretically possible. And then you have places like Titan, which is a moon in the solar system, which has basically oceans and rivers and rain and thunder, but instead of water, everything is made out of methane. Methane ice, methane lakes, methane rivers, methane rain. Methane is a very shitty molecule to make life out of, though, because it doesn't stick to itself the way that water does. Not a great solvent. So we don't know if that would be possible, but it's been suggested too. Problem is, we can't really create life in the lab. It's never been done. So it's not like we can run experiments to know what life evolves more easily. You'd have to see it.
You're saying we haven't created life.
No, we haven't.
But we can clone life. Isn't that a way of creating it?
That's a lot more easy than getting
Well, you're still
random
creating
blocks
it,
to
right?
assemble.
I think
Yeah, but-
that's just... It's closer to reproduction than to creating life.
It's closer to creation than evolution.
Yeah, that's what I'm saying. Creating life, if you clone a creature, you start from nothing
Yeah,
and then you have
Sure,
just a
that's
bunch
like,
of stuff and then you have a clone.
That's
So-
the same as us bringing microbes on Mars and being like, oh great, we created Martian life. You know?
That's not what cloning is.
No, I mean, if it's manufactured life, it hasn't evolved naturally. They're completely different processes.
No, but you said that we can't make life in a lab. We can.
I mean, make life from non-life. We make life from copying other life.
Yeah, but you still start from inanimate material, right?
No, you start from a cell, you extract the DNA from the cell.
Yeah.
Well,
And
you
use that
you don't
DNA
take
to-
a bunch of carbon and make it into a
Really not.
into a horse.
Absolutely not.
Okay.
And we get the DNA from a horse cell.
You don't pick a bunch of carbon and you do some Full Metal Alchemist thing and you convert things into life, no?
Even if we could, which we can't, even if we did that, it wouldn't give us any idea of how likely it is to evolve on its own.
Okay.
Because we mean life on Earth evolved by evolution, that's why it was so slow. It wasn't created. Of course, if you create it from a template by copy-pasting something you already have, it evolves a lot more quickly. You can just make it happen immediately. Like dropping microbes on Mars. You haven't made Martians. Which we have, by the way. Our probes we sent there were not sterilized enough. Very likely there are now Earth microbes on Mars. So we have made Martians.
Yeah, you heard it first. We have made Martians.
If you count microbes.
We have found life on Mars.
Yeah, we lost it there, but we found it again.
Yeah, I mean that would be a nice headline for a newspaper. You know, they like those misguiding articles. Life on Mars found, and the subtitle: we actually brought it there, but that's not.
We didn't clean the probe well enough. Sorry, guys.
Details. There is life on Mars, so it's Martians technically.
Statistically, some of those microbes are still alive.
Yeah, Kenny is happy that I dropped a Full Metal Alchemist reference. I know that he's listening to us.
Yeah.
But we have another question from Cancrovantus, and I did mention earlier that we can't see planets on a perpendicular orbit to our point of view because they don't pass in front of a star. And he is wondering if there is an estimate of how many of those planetless stars might be. I'm not sure how can we even guesstimate that.
No, we can, because the distribution of orbits compared to us should be random. You can see it in Elite too. If you go to a random system and you look at the plane that the planets prefer, they all go in the same plane usually. They all go on the same flat thing. And the orientation of that is completely unrelated to the galaxy orientation. Because when the solar system forms, it doesn't care where the galaxy is. So all inclinations are equally likely. So knowing that, and we know how many we see, we can know what fraction we're missing to. We can calculate how many would be edge on just by chance. So current estimates, it's at least 3/4 of all stars have a planet. At least 3/4.
That's amazing.
Have at least one planet.
Any kind of planet, of course.
A planet. At least
planet.
One. Well, on average, the stellar systems we see have more than one. Not quite two, I think between 1 and 2. They tend to have more than one. The ones we see, anyway.
Okay, guys.
Okay, sorry.
Yeah, no, I was just going to say to please ask questions in the Dangerous Cosmology channel, but Scaleus did that before me, so that's great. But yeah, we're going to. I hope that answered your question, Cancro. If you have more, feel free to ask. We have more questions from Dr. Nagi, which again, some of them may have been answered while we were talking. Because yes, actually, I think this one was answered because it was asking how old could the oldest civilization of the universe possibly be. We just said that, the quasars at the center of galaxies sterilizes life, so it can't be that old.
But not all galaxies have had active quasars. So especially the small galaxies. The smaller a galaxy is, the more stable it is, basically. But it's a trade-off, because if you're too small, then you don't form enough stars, so you don't have enough cycles of enrichment. So it's a trade-off. If you're in a very big galaxy, like what we call the biggest clusters of galaxies, they had the golden age of star formation about 6 or 7 billion years ago, where they consumed something like half of all the star-forming resources in the universe. They were eaten up during the cluster golden age, basically the big capital cities of the universe. But they were also very violent. They had lots of galaxy collisions, they had lots of quasars going on, lots of very dangerous light, so UVs, X-rays and gamma rays being fired around. So that's too big, probably too unstable. If you're too small, you don't form enough stars and you don't get to recycle your gas often enough. So the things we're made of, the sun and the earth and life, had to be enriched, we think, at least 3 times. So it's been through stars 3 times to get to the concentrations of carbon and silicon we see. So you get pure gas, it goes through a star. When it's expelled, there's a bit more pollution in it, like carbon. And then the gas cools down and forms other stars. And you repeat for 3 generations before you get to the level of the Earth. So it's a trade-off. The biggest galaxies in the universe started way earlier, and they formed many, many stars, but they were maybe too dangerous for life. While the very small ones are a lot more stable, but they're not rich in materials. So maybe things like the Milky Way are optimal, but that's a bit hard to know. How early you could go is a very valid question. How long you could survive back then is a good question too. The building blocks of life we see as early as 1 billion years after the Big Bang. You start getting dust grains, carbon and silicate grains that then, we know they're the building blocks that later form planets. So the building blocks are there very early. Maybe not enough of them yet, and maybe the environments are too violent. So it's a big unknown, pretty much.
Okay. Well, okay, we have quite a of scattered questions. I'm going to take a few from different people so that
no one
we don't
gets
risk.
neglected.
Yeah, exactly. And we have one which is quite elaborate from Volkrov the Viking. Vikings still exist, apparently.
Yeah.
Oh, that one. I saw that one. I saw that question. I had no idea what he was talking about.
Okay. Well, Volkrov the Viking, if you're listening to this and you're not out there fighting giants or drinking in Valhalla or whatever Vikings do, just drop a few lines in the chat if you can just... I'm just going to read this, because maybe someone else can help. A recent closed United Nations committee meeting addressing to the current president of the United Nations, Maria Fernanda Espinosa Garces, I'm not sure if I read that correctly, and the General Assembly, claimed that a NASA operational task group has made contact with a massive, non-aggressive extraterrestrial object hovering above the US Pentagon on December 19th, 2018 at 4:07 p.m. Was this event authentic? Or it was just a series of deepfakes, celestial static, and pre-production footage for a movie?
I have no idea. I don't follow UFO news.
Yeah, usually they're not real, especially if they always land in America and always on the Pentagon. I mean, that sounds a bit very Hollywood-like. I mean, why would they land on the Pentagon? Does it look like a landing pad for a new UFO? Maybe, you know?
Yeah, it's a docking port.
I mean, why would you go to the I mean, if I were an alien, I would go where most people are, like China or India. Why is always the US?
I don't know. They like America, right?
The US military.
No, I mean...
And if they just hovered over London, there'd be enough people taking pictures, it would be undeniable.
Yeah, but also, why the Pentagon? I mean, do they know that they have... They are supposed... That is the organization that deal with this? How could they know? And, I mean, what... Anyway,
They're
I don't know.
not the only ones that deal with this.
Yeah. I'm not sure. I haven't heard about this news either, and...
I don't know, I googled it, I can see the event he's referring to, but even in December there were like 3 others. I don't know. I would need much better evidence than some YouTube videos.
I would like to think that... sorry, we have a cat literally in front of the monitor. I can't read questions at the moment. Yeah.
Cat is trying to drink my Baileys.
No, don't. Okay, no, I was saying... move. Shit. Yeah, no. I mean, thing is, if that really happened, I'm pretty sure that someone would have taken pictures that are accurate and consistent with each other. I'm talking about hundreds of people from different angles.
In this case, there's like free. There's like free videos that show it. But I mean,
well, wait a second. Those videos that I'm looking at now, they seem to be at night. This one is at 4:07 p.m. So that's afternoon. So it would be full of people taking pictures, and they would all have to be consistent. We're talking about the day, not during the night. They would have to be consistent from different angles. And if that was a thing, we would have known by now. It's as simple as that.
I just don't really believe it.
Yeah, I mean, it's not a matter of believing. If this happened, it would be all over the place, and it would be a big deal.
Yeah,
the fact that it's not a big deal. The fact that it's not a big deal, it means it was not a deal at all.
Yeah, it would require suppressing all the photos which thousands of people took, except for free shitty YouTube videos.
I think you can only believe this if you're a conspiracy theorist or something.
Yeah.
It's a bit of a hard one. These sightings are not very believable.
It's one of these things. I mean, if things like of this magnitude happen, everyone would know about it pretty much instantly.
In the era of smartphones,
I mean, there is no way you could keep silent about this.
Yeah,
it is just irrational to believe that such a thing could be hidden. It just doesn't happen. What is instead quite true is that I now can't literally scroll the chat because my cat is sitting on the mousepad.
Bad cat.
Is stopping me from doing what I'm supposed to do currently.
Well, I can scroll the chat. Just tell me from where to where.
No, it's fine. It's fine. I just have to use the cat as a mousepad.
Oh, okay.
But
hope she likes it.
He doesn't seem to mind.
It's a he.
So let's move on to Hoyer again. Okay, his question, I believe it is missing some words because I think he meant, what do you think? But the question is, what do you about active SETI? I think there is a word missing there. What do you think about active SETI, I guess?
SETI is search for extraterrestrial.
Yeah, no. Just the question is missing.
Yeah.
Missing.
Do you it favorable or dangerous?
Yeah. Do you think it is favorable or I guess? Do you think it is good or bad? Try to look for life. I mean,
I don't see why not. We've always explored our surroundings and our galaxy.
Yeah, I'm not sure what he means. If Hoyer is listening.
No, he carries on. He says, I can see the question. New Horizons is one thing. Radio signals with Earth's location going to other galaxies is a complete danger, in my opinion.
Oh, right, because we're saying, oh, hey, guys, we're here. Come bomb us. That's the risk, right?
Well, that vastly overestimates how far we can reach. As we mentioned earlier, we've only been broadcasting radio at all for about 100 years. It will probably never reach other galaxies. Even if we are broadcasting it in all directions, it's just way too far. Even to reach the other side of the Milky Way, you'd be looking at tens of thousands of years.
Yeah, probably only someone will actually pick it up when they are passing by with their spaceships. In frame.
Or I guess they could have set up a network of listening posts throughout the galaxy or something esoteric like that.
But I
don't think broadcasting our location is bad. I think it's
would have had to be near us at some point.
Yeah, it depends how much sci-fi you want to believe in terms of how fast they can travel, where they've been before, what kind of networks they can establish. I mean, we just don't know. Even if they left probes behind around a lot of solar systems, we haven't found such probes either. So currently there's really nothing to be seen. And as I mentioned earlier, the amount of stars we can even see life from, if it's there, is very small. So if you copy-paste the Earth with our technology, our radio broadcasts, to 2,000 light years away, we would not even notice with our best SETI telescopes. It would go completely unnoticed. We're not at that level yet.
Okay.
And that's a very small part of the Milky Way.
But I want to be.
And yeah.
Yeah, I know.
Well, Hoyer M is also asking if it is a possibility that there could be life in the Venus clouds.
Ooh.
He has read a sci-fi book about this, and he has never heard about this concept before. He's still talking about microbes, methane breathing.
It's really stretching what you mean by life, really. Because if all you need is some sort of molecular process that when it comes into contact with raw building blocks, it's able to assemble them. If that's your definition of life, then it could be anything. It could be tiny structured gas clouds just absorbing heat from the surface of Venus and just like floating up and down. Something like that could be defined as life. It's not inconceivable. It's been suggested that all you may need for life is complexity. If any system allows complexity, life will naturally come out of it, even if it's not in the form of carbon or molecules. And some people even say silly things like computer viruses are alive because they reproduce themselves. They on their own infect new computers and make copies. And they're not made of anything physical. They're just information of sufficient complexity.
Yeah, well, that would actually, if that were true, that would actually make a lot of things alive. Like my computer or my smartphone.
Well, if it reproduces itself, right?
Yeah, well,
smartphones don't build smartphones.
Yeah, okay, but the software end can be maybe not under the same conditions, but it does reproduce parts of itself while updating, for example.
Yeah. So if that's your only definition, making copies of yourself on your own, then any sufficiently complex system might have life, quotation marks.
Yeah.
Even something like a gas cloud floating around the universe, if there's enough chaotic motions, enough complexity going on, it could assemble into patterns which resemble life.
Okay, well, on this, still on the SETI subject, Rusted Bulk Mike is saying that the SETI search tends to focus on the known examples of life, like carbon-based stuff like that. But has there been any consideration to receiving signals from a civilization operating on a different timescale from us? He's mentioning as an example the Ents from the Lord of the Rings, the ancient trees that are just older and slower than us because their metabolism is just works on a different timescale. So he's talking about extremely slow, maybe even machine intelligence that operates very slowly to optimize power consumption and stuff like that. And this, I think, brings us back to signals being sent at large intervals that may be repeating, but they're just too slow for us to interpret as actual artificial signals.
Well,
so we have to wait. We have to wait for millennia to just hear a word. Is it something that's been? Yeah, no. I think he's asking if there. I think he's asking if there is any actual initiative, any actual search being done on this.
I don't think we can actually search for that because that's so far beyond our technological capabilities that we wouldn't know how to detect it.
But we have been monitoring the entire sky for as long as it has been possible. We're going on 20 years of the Sloan Digital Sky Survey, which took pictures of literally the entire sky, or as close as it could get. So we've been making full sky maps and checking what changes in them from as early as it was possible. And you have systems like NASA's Sentry program that constantly monitors the entire sky for new asteroids to see if anything is moving, if anything new is appearing. So we have actually a lot of pictures of the sky imaged at different points in time going back decades, of the same bit of sky being imaged again and again every few days. So in that sense, we have been looking for it indirectly, just by monitoring our environment.
And of course, nothing is showing up.
Well, lots of things vary on slow timescales, like variable stars can oscillate quite slowly, that kind of thing. Repeating bursts from dying stars that happen every so few years, things like that. But no sign of intelligence, no pattern.
Right. Okay, just we have to wait a few thousand years to see if there's any end up there.
Or monitor even better. I think we're getting there. We're having whole telescopes dedicated to monitoring by now because we take the asteroid threat so seriously nowadays. It gets a lot of funding. People are really afraid. NASA is funding it like hell. So we are monitoring, at least, as well as we can.
Right. So, a question from Thorbot Hansen, who sadly is not here with us today. Do you think it is possible that the origin of life dates back to when the density of the universe was such that microbes could have inhabited the interstellar medium and fed off pockets of heavier elements generated by early supernovas?
No, by the time there were elements made by supernova, the intergalactic medium was already not dense enough. So that specific scenario wouldn't happen. The very first birth clouds of stars, even there, the only parts that become dense enough for chemical reactions to take place are in protoplanetary disks that get carried away by stars after they're born. And those turn into planets anyway. So could microbes form just in a protoplanetary disk, just because the elements float around and are kind of heated by the star? Could that happen? I don't think so. I don't think it's a very good place for chemistry to take place. You're just too bombarded by UV and X-rays from all angles. Early on, you also had the CMB, the cosmic microwave background, which wasn't made of microwaves at all. It was deadly, deadly rays back then.
It was the gamma ray background.
Was it? I don't think it was ever quite gamma rays, but it was enough to be quite prohibitive to complex molecules forming.
So even more unlikely than it is now.
Out in intergalactic space, I don't think is a very good place for life to prosper. You just don't get much chemistry there. And all self-replicating processes require chemistry, the bonding of protons, electrons, and so on. In an atmosphere, maybe it could be dense enough.
Unless it's a non-corporeal life.
You still need some sort of process, something that can make copies of itself, and the only way to do that is really chemistry. There's not much else. You assemble atoms to make structures.
There is energy.
Energy doesn't really bind to itself to make structures.
Not that we know of.
No, the space-time is pretty featureless. It doesn't have small details in it.
Okay.
So I suspect not.
I don't have a comeback for that.
Yeah, I guess
I've heard
that.
it before. I think it was something called like the Laplace cloud or something. It's back to what I said earlier about complexity. In very, very convoluted scenarios of...
The name rings a bell, but I don't know anything about it.
It's just saying you could have a brain just made out of gas as long as the complexity was high enough and different parts of the cloud would communicate using light in a way that the brain does. I think that was the basic idea. Like just using thermodynamics, you could get enough complexity just in a cloud of gas. But I'd say in practice that wouldn't happen.
Isn't that like the Boltzmann brain or something?
Oh yeah, that's it. Thank you.
Yeah, Boltzmann brain.
That makes sense.
Not Laplace.
Yes. Now I got the connection.
I know more than you. Haha.
Yeah.
I don't remember.
Can I have a PhD now?
You can have a cookie.
Well, you can.
I think it's enough knowledge for a PhD.
I will share my Baileys with you.
If we
Yeah.
had a PhD in distant radio, you'd get that.
Right.
Out
Yeah.
of pity.
Thank you.
Oh,
Sorry,
Hon-
that's not
honor-
true. Nightfall knows a lot.
Honorary. Yeah. Sure.
that
Anyway,
being a perfectionist
we have
comes with that feature.
paper hair plan.
Paper airplane.
Wait, no, hairplane, hair.
Airplane.
Paper hair plane.
But that's not what's written. It's paper hairplane.
Many spelling mistakes.
Paper
Good job.
airplane.
No, I think it's intended.
Yes, it entirely is. I hope
Okay.
so.
When he's asking if we did bring microbes to Mars, what are the odds that they actually could survive? Isn't the atmosphere wrong for Earth-based life? And even if it was fine, wouldn't it be too cold where the rovers are? So basically he's saying, yeah, we have microbes, but they basically die as soon as they get there.
They wouldn't replicate themselves, but they could survive for a while. And they're pretty sturdy. We find microbes on Earth, even in deserts, that look pretty inhospitable. Very high and very low temperatures. And small creatures called tardigrades can even survive in space.
Yeah, but we don't bring tardigrades on Mars.
Yeah, I mean, if someone came from outside in the lab with dirty boots, now there's tardigrades on your rover.
Really?
I don't know. Nothing is ever completely clean, right?
No,
even when the rocket took
Yeah,
off,
but
it
are
had to go
tardigrades
through-
that common?
Not really. They
So
mostly live
I
in
mean-
forests, but it's not impossible. Like, the rocket still has to take off through the atmosphere. The atmosphere carries microbes and pollution and particles that microbes live on. So just by passing through the atmosphere, the rocket would get polluted. There will always be a small amount, and they're pretty sturdy. So even if they don't thrive necessarily, they can live there for quite a while.
Yeah, because let's remember that panspermia is still a valid theory, right?
It's still a thing.
So it didn't come up in the questions, but we could be the aliens.
Yeah, I find that a bit stupid. You're saying, look, microbes arrived on Earth from meteorites that they were stuck on, which is basically the theory of panspermia. Okay, great, but where did those microbes come from then? Right, they still have to come from somewhere.
Perhaps.
Yeah, no. I mean,
And-
of course, it's not. Of course, it's not answering the question of the origin of life in the universe. It's just answering the question of life on Earth, because
Based on simpler life. But it still has to evolve, and it still takes a really, really long time for them to evolve into something useful.
no. What I'm saying is that if that was the case, it means the life was formed somewhere else.
Sure,
First,
but it wasn't
and-
interesting life.
Well, still life. I mean, life with the potential to be interesting is still something remarkable.
Yeah, given 4 billion years to evolve.
Yeah, well, 4 billion years is not much.
It is, actually. It's like a quarter of the life of the universe.
A quarter.
A quarter of the entire life of the universe.
Yeah, I mean, it's a lot, but it's still a quarter. It's not even half.
Yeah, let's seed this planet with microbes, and let's wait 1/3 of the age of the universe
Yeah,
for it to
I
become
mean,
interesting. Very efficient.
If you buy a pizza, 1/4 of pizza is not much of pizza.
But would you wait 1/4 of your life for the pizza?
Well, we sleep and work most of our life, and we're fine with it. We have fun for the rest, and which is very little time, and we're fine with it, right?
Well,
I guess it
actually
just-
working and stuff like that can be fun too. Hashtag
Okay,
science.
usually it isn't. So we waste most of our life, and yet we don't seem to care. So why not? Maybe it's just not that big of a deal.
It's just not efficient. You know,
I-
you would see that at a slightly more useful point, like a tardigrade. which
Yeah,
is
but
like-
the
which is at
universe-
least an animal.
Yeah, but you're saying that life takes 4 billion years. And yes, it is quite a good portion, but assuming that the universe will never get older than this, if the universe gets 100 billion years old, 4 is not that much.
No, I'm just saying, if someone seeded it, it was a very, very inefficient plan.
Maybe to them, 4 billion years is like 5 minutes.
Except it's not, because the universe hasn't been around that long. To them, 4 billion years would be like 1/3 of the entire life of the universe so
Which
far.
could still be 5 minutes for in their case.
Then,
maybe
they
they're
then they
maybe-
would have only been alive for 15.
in their perspective, maybe it
They
has.
don't have technology in 15 minutes. Come on.
Yeah, maybe their time frame slowed down over time.
It's sci-fi by that point. I find panspermia a bit circular. If it's intentional, it's very inefficient. If it's not intentional, then life still came from somewhere.
Yeah, again, I don't think it's supposed to answer where lives come from in the universe. I think it's just life on Earth where it comes from. I think that it's a theory for that, not for life in general.
And the other thing is what we see sometimes in Elite. When one planet in a system has life, the other planets in the system tend to as well. Right? So panspermia is kind of assumed in Elite. That's why life tends to cluster in the same systems, and that's quite realistic.
I don't know. Maybe what Elite assumes is that if there is a condition for a planet to develop life, also other planets are likely to have the same conditions.
Oh, it's not even that. We have proof of bits of Earth and Mars ending up on each other. Just because occasionally you get big enough collisions that we have Mars soil meteorites that have made it to Earth just from the unlikely event of a big collision, knocking them into our orbit, and the opposite too. So if you just wait enough millions of years, eventually bits of planets will merge. If you have things clinging on to rocks, they will spread through your system. And that's quite well known.
Okay. Well, no, I mean, I'm just trying to give you ideas, It's like when you throw science at the wall and see what sticks.
Yep, that's what I do. The answer is less than 10%.
That 10%
My life is sad.
That 10% is still worth a Nobel Prize, maybe.
No.
Well, eventually. I mean,
not for most people, though.
Yeah,
being able to cope with. Yeah.
I don't know if the Nobel Prize is actually still as significant as it was like 20 years ago. I mean, it's been given for stuff that, didn't, what's it called, deserve it.
Well, the physics ones all did. I'm gonna defend that. All of the physics ones were reasonable.
Okay, yeah, I can get behind that, but still, the name Nobel Prize is still... It's lost some traction, I think.
Well, in some of them, maybe, but...
for scientists to achieve stuff.
It's because things like literature and peace are just intrinsically subjective. At least the physics ones take into account the technology implications or the range of things that have been impacted by it. The physics one is a bit more objective.
It's easy to quantify, and the impact on things, the ramifications of discoveries are, everyone can see them. It's not a matter of opinion. So,
or sometimes just the philosophical impacts, like when we discovered the accelerated expansion of the universe and dark energy. Everyone knew about it. It's a big deal. Well, the Nobel Prize of Literature, I don't think I can name more than 1 or 2 books. They don't reach as many people. I can name a few. And to be honest, they're good, but I don't think they have the same sort of civilizational impact than discovering our place in the universe or the transistor.
Right.
That's not me being a snob. I think that's a fair opinion.
There was a follow-up question on YouTube, possibly the delay. Anyway, it was
from 2 hours ago.
Yeah,
you're slow, Michael. You're slow.
No, it's just pop up. Well, it's about microbes on Earth and Mars, but the question was, well, wouldn't Earth microbes then land on Mars much sooner than us taking them there? In other words,
yeah, they might have.
Wouldn't microbes be all over the solar system by now?
Well, they can't really spread. They don't have anything to eat. Microbes still reproduce themselves by assembling building blocks, like the basic acids and bases that just don't exist on Mars. Plus, they usually need some sort of solvent like water or something similar. So even if they get there, they can't reproduce and spread necessarily. They don't have the building blocks they need. But they would land. I mean, we were worried when we sent the rovers on Mars that were aimed at finding life. We would just find the life that was brought there from Earth. that was still left over. How could we know? If we found like a strand of DNA, how do we know it lived and died on Mars, or we just brought it there and it died 5 minutes ago? It's a decent question. You have to have a way to tell. I think if it was too similar to something on Earth, like if it was literally the DNA of a microbe that we know, would be a bit suspicious.
We could use carbon dating to determine when it died, can't we?
We could. I don't think the rovers currently carry carbon dating experiments, but if they could bring it back, or if we had a lab there, then we could.
Yeah.
We're not there yet anyway, because we haven't found DNA on Mars.
It's not going fast enough for me.
I think we've been careful not to, not to send any as much as we could.
But statistically, they have landed there just by the meteorite contamination. In the 4 billion years that we've had microbes, there have been collisions, even big ones, and things get flung into space reasonably regularly.
So the possibility is quite high that those microbes are on Mars, or maybe the other way around already.
How long do they live is a different question. For example, we haven't had a major collision in something like 10,000 years. Can microbes survive 10,000 years up there? Probably not.
Okay, Van Otter is the one who asked the question. He has another follow-up. Wouldn't they get some of that in clouds of Venus and Jupiter?
Yeah, they would too. Again, it's unclear if they would survive, especially in an atmosphere like clouds. The typical assembly procedures that bacteria and microbes use, they wouldn't work. They're very simple creatures. They only take building blocks that they find and they put them together in a very simple way. And those blocks just don't exist in an atmosphere. In Venus, they might be puffed up by the clouds. They might not fall to the surface. There might be enough winds to keep them suspended in the atmosphere. It's possible. I'm not sure how long they would live without the ability to reproduce. Even on Titan, where you have rivers and such, it's not rivers of useful stuff. We haven't found many building blocks of life outside. Although that comet, Cherenkov, apparently that had some. That could have had some of the building blocks. Amino acids.
Yeah, and actually, Kenny was asking a question, and yes, we haven't asked it yet, and he's listening now. We're going to ask that because he has to leave.
Oh wait, just a second
shortly.
With that. Van Otter has been asking another thing. He didn't mean the microbes themselves being in those clouds, but the food.
It would be, but it might not be in a state that can be used chemically. So, for example, microbes on Earth always use water as a solvent. Basically, you have to, like a glue, like a chemical glue of sorts. If you want to get two molecules to stick to each other, they won't always want to in the absence of water. And these things, these microbes have been on Earth basically unchanged in this assembly process for billions of years. And they're very tuned to an environment that is water-rich and the correct temperature. And in terms of chemical reactions, a lot of chemical reactions don't work if you change the temperature or the density or things like that. Not impossible, but it's not what they're made for. They would probably not live too long.
Okay.
Okay, now you can get to Kenny's question.
Yeah, okay, no. His question is about the Galileo mission. Because during this mission, it was found that Europa may be generating its own magnetic field. It is believed that there may be a global ocean made of salt water beneath the miles-thick icy surface of this moon. So, his question is, with a salt water ocean and a small atmosphere made of oxygen, may Galileo be our best chance of finding extraterrestrial life, even if it is microbial? Basically, can Europa be a possible candidate?
Yes.
One of the most promising candidates, actually.
It is probably the most promising candidate for native life outside of the Earth currently. Because when Galileo was over there, Galileo was a small satellite. It was flying around Europa, which has a very thick ice crust, and it flew through a plume of water being jetted out from under the ocean. Basically, there was a crack and a big jet coming off, and it flew through it, and it could analyze it when it was flying through. And it had things like salt and some such things. and water. So we know that under the ocean and under the crust, there is at least some water. We don't know exactly how deep or how much. It's not completely frozen because thanks to tidal heating, basically, because it's so close to the planet it's orbiting, it's being squished and stretched by its gravity. So the center of it is being heated. It's keeping the water from freezing. So it's kind of warm. It has water, it has salt. So definitely a great place for microbes to live. And the most promising place we're currently looking at for native life.
It will still be hidden under the crust, though.
Yeah, but we have a bunch of proposed satellites to go and explore it, even land on it and just like drill.
So it is actually more promising than Mars, obviously, right?
Kind of. At least there's liquid water.
But
there is some liquid water on Mars, but clearly less. Yeah, there was even that amazing. Sorry, I have to say this because it's so cool.
Go ahead.
There was this amazing mission proposed, I think, by ESA, of sending a submarine on Europa. So it would land, it would drill, and then it had a small drone submarine that would go and swim around the ocean of Europa and take pictures and stuff.
Well, why not?
It didn't get funded because it was too expensive. But one day, maybe. That would be so cool.
Yeah. We spend a shit ton of money on useless stuff. I mean, we could find life, and we're not... I mean, How expensive could it be?
I don't know. I don't think it got funded in the first run.
People prefer to buy iPhones.
No, well, I'm not talking about that, but...
Well, the government always has a set amount of money for space missions, and then all the teams of astronomers have to compete to have the best idea. And then some politicians meet in a room and they interview you and they pick the best.
Of course.
Yeah, but why politicians? They don't have the
because they represent the people, and the people have to decide how to spend their tax money.
No,
I'm sorry, that's how politics works.
The people don't have the qualifications to exercise free will.
But they pay, so... But they pay, so we have to respect their wish.
They pay, but they don't have the knowledge to decide where it goes.
Sorry, people, no offense, but it's the truth.
Yes, you heard it first. Distant Radio 3305 is against democracy.
Right.
So we are against democracy because we believe that science should be...
We are currently under federal government, as you can.
No, we are imperial. What are you talking about? You may be under
imperial.
Hush, yes, hush now.
We follow our glorious princess. With beautiful blue hair.
Don't expose us. Damn it.
What?
Distant Radio funded by the Empire.
Of course.
Yes, but sailing.
Actually by Nova Imperium, but that's a secret, right?
You weren't supposed to say it out loud.
Shit. Okay. Well, never mind. But yeah.
You didn't hear anything.
No, in fact, all hail the Empire. But anyway, let's continue. So we have...
Exactly.
Yeah, we are almost out of time.
Wait,
but...
No, limits.
Well, yes, we are out of time. Almost.
We have 15 more minutes.
But we do have...
Let's go through questions.
Yes, please.
Yeah, no, I was trying to see if Kenny had something else.
No, let's ask the recent ones, so people who've been listening in can hopefully get an answer. Although you're always free to tag me or just talk to me on Discord, I answer to all DMs.
Yeah, I know, of course. I was just checking if Kenny had other questions because he has to leave, but I don't see...
on my keyboard.
I don't see any other question from him, but... Okay, Paper Hairplane is proposing to fund this project. He has a few billion lying around, and he likes space. So yes, we'll give you the PayPal information of Dr. Shoba. You can donate those millions directly there. We can guarantee you that they will be used for science.
The only requirement is... yeah, we all get the first ride to space, if you ever... Well...
If I ever invent a warp drive, I will ruffle some of the spots to distant world listeners.
You've got to go head-to-head with Elon Musk and... what's his name? the one of Blue Origin, the Amazon.
The guy from Virgin too.
Okay.
Virgin Galactic.
Yeah. All
Yeah,
those
I mean,
guys.
that would be the first space war between SpaceX and
Well,
Amazon and Virgin.
building a space elevator is the thing to do, or a base on the moon. And
Yeah.
either way, I'd be on board.
Anyway, yeah, Kenny had a follow-up, which a possible issue, he says, would be a radiation for Jupiter. I think he was talking about Europa still. Would the ice and water be a good protector against it, against this radiation?
Yes, excellent.
Yes.
It would be an excellent shield. Very few things can stop radiation better than a thick layer of water.
Yeah.
That is
If
a
people
very good
wouldn't-
way to stop radiation.
If people didn't know, you can actually go swimming in a radiation pool that is being used for cooling down rods used.
In
Nuclear
nuclear
fusion.
reactors, it's actually safe to swim in the tank because the
Yeah.
water is so good at absorbing
Can
radiation.
you drink it?
No, don't drink it.
So how come if you play Fallout, you get irradiated if you swim? In
Unrealistic, of course.
Kind of. You'd be less irradiated than if there was no water. But of course, if it's literally uranium barrels at the bottom leaking uranium, then it's not the water that's poisoning you, it's the uranium in the water.
Yeah.
No, I think that's not the case in Fallout. It's just every water is irradiated.
So our first offline meeting will be swimming in a radiation pool.
For science, we need to test this. Of
Yeah.
course, Michael will be the first. And will monitor
I've got
the
no
effect.
problem.
Yeah, so Europa should be fine. It would be so cool to go swimming up there. Only 0.13 G.
That's easy to land on.
Very easy to land on. And you would feel really light and jump really far.
Yeah, but we need to wait for space legs.
Yeah, I guess we have to. Anyway, let me just double check if we have some other question we can quickly answer. If you're listening to this, this is your last chance
I
to
see
ask.
questions.
This is your last chance to ask questions live if you want them answered. Yeah, no, I think we left some behind from Nagi actually.
Yeah, he had a lot.
Yeah, I know.
Oh, I see why.
He's greedy. Well, he was okay. Let's talk about elite
Greedy
because
for knowledge.
yes, greedy for knowledge,
Yeah.
and we have Thargoids in elite, which is one of the two known life forms apart from humans. The other ones are the Guardians, but we haven't seen them yet, if they still exist. The Thargoids are supposed to be relatively realistic in a sense that it is reasonable to believe that life forms like the Thargoids could exist. They don't resemble the typical aliens you see in sci-fi because we tend to humanize them with 2 arms, 2 legs, just with big eyes and elven-like features. But the Thargoids are not like that at all.
Yes.
So you agree that they're, in a sense, realistic?
That's a lot more realistic than the usual images we have of aliens. I think people don't always realize how arbitrary the human shape is. The only reason that our limbs are proportioned in the way they are compared to our body is due to our evolutionary history and constraints. It's not more practical or better than another body plan. If our joints bent backwards, or if our shoulders were locked in some way, or in any shape our body could have, it entirely depends on what you evolved from and in what circumstances.
Okay, guys, you heard it. Thargoids are real.
Well, they're more realistic. There was a guy, I can't remember his name, a guy who designs realistically evolved aliens. So he goes through the entire process. He says, in this environment, maybe having this body plan would give you an advantage.
Yeah, I think.
But then you'd be stuck with 2 arms, so you have to carry that around for the rest of your history, and it's basically a constraint.
You can just play Spore and see what happens, I guess.
Well, Sport just looks ridiculous most of the time. But
Yeah,
it was
so,
a
I
concept
mean-
artist, wasn't it, who did those designs?
Yeah, there was a famous artist. I can't remember his name. It's bothering me. I tried Googling it, but it's not coming up.
Wasn't he the one responsible for the alien design?
He might have been. I think he was a consultant on that. And for the Arrival aliens. That was a great movie.
Oh, The
was
Arrival.
so
Yeah,
good.
I actually
haven't
like
seen
that.
Arrival.
It's so good.
I think it is actually relatively realistic in a sense that
Well,
it deals with, the difficulty is that the first difficulty you would have with an alien race that is actually alien in the very sense of the word is how do you communicate?
Yeah.
Because, it's not like, oh, they just speak a different language. Not really. Why do we assume that they actually have a phonetic language at all in the first place? They could communicate in a completely different way and even if they have a language, so to speak,
How the hell are we going to understand
it could be anything. It could be visual. It doesn't have to be sound. It could be completely different than what we can't even think. We see something or we notice something. We couldn't even start to guess it is their language.
Yeah, I
So
mean,
it's
think
not-
about it. Even some tribes in Africa communicate by making clicks with their tongue. They just communicate in clicks.
But that still sounds.
It still sounds, but if you
can-
came across that in the desert and you tried to communicate with them, you'd have no idea. Like, how? You have no common reference. And that still sounds. So,
Yeah, it's still a code though. I'm thinking, I don't know, maybe someone is trying to communicate with us using cloud shapes.
yeah.
I mean, you wouldn't even see, oh, that's a language. No, it's not even, you can't even reach that start.
Yeah, maybe
So-
not even cloud shapes. Clouds might be too fast. Maybe rock formations.
Yeah, no, anything that
Yeah.
to us, it couldn't even possibly be a language at all.
So
It's something that's very often taken for granted in sci-fi, but it's really not. It's a big problem.
So
I'm
that
afraid
that
to say
movie
it,
dealt with
but
this, and
how about crop circles? They
Yeah.
they are a form of communication. That much could be determined already, couldn't it?
Yeah, they probably mean something. They have some symmetry. It would be useful if we knew who was making them. Why do they only do it at night?
Yeah.
and not over the Pentagon. But
Still, are there
But yeah.
parties working on decoding this? Or
Most
maybe-
of them have been tied to specific groups making them. It actually takes a lot of people to coordinate to make them.
Yeah,
And
but,
we know mostly what techniques they have to use. So most of them have been tracked back to the people who made them.
But
sadly.
if I would make such messages, I would, or such stuff, I would encode a message in those. So I wonder if people are actually working on decoding those, or if there are solutions available.
yeah, but what's the point?
Some people are, but different
No,
groups don't
It's
have
for
the same
fun,
meaning.
For the fun of it.
For
I just do it
fun.
for the
It's
of it.
basically real life ARG at this point.
Yeah,
I mean,
that's
you're
fun.
like, well,
Yeah, that's pretty fun. Nothing wrong with that.
yeah. But as long as you take it as a game, sure. But
I mean, there
So
was this
that-
game called Ingress for anyone out there who's a total nerd,
Doesn't
and
have
that
much to do
involves.
with,
Yeah, but it's the
life.
same. You walk you walk to a place in the real world, you capture it, and then you can link it to other places in this virtual reality. You still have to walk there physically, and people used to connect them and making links that spell out things or codes. And you could only see them from the online VR map.
usually it's the shape of a penis.
That
That's-
happens, yeah.
yeah, I mean that's the first thing that. I mean, if you were an alien, you go to a planet and you shape a penis, right? That's the first thing you do.
Of course.
They wouldn't know what it is.
An alien.
How do you know? Maybe they watch porn.
Yeah,
Jesus.
our porn, of course.
Our porn, yes.
Yes, Scalios. Ingress, yay.
What?
So I think that answers. No, wait.
Yeah,
There is
Ingress.
another question from
like that too.
Nagi, which hopefully is quick to answer. Could there be ringed Earth-like planets?
Yeah. Why not?
I
don't know,
follow-up
maybe-
question.
Pretty
How would
unlikely, but-
how would that affect tides and stuff? Ocean tides.
It could be a range of things. It's a lot of things are possible. The most likely source of rings would be a big impact with the planet. That would probably kill life, like when the moon was formed. Back when the Earth was very soft, it got collided by a Mars-sized planet or a bit smaller, and some material flew out, and we had a ring for a while before most of the ring glued together into the moon. This is why the moon is made from the same stuff as the crust of the Earth. It's really the same chemical composition and different from all the other planets. So it really came from us. But the problem is that would probably destroy life if that collision happened on a scale like that. Although that's one way to make rings. If something collided with the moon, you would have a ring for a while, and some of it would fall back on the Earth too, as big meteorites and stuff, but we might survive. The thing is, rings around something as small as an Earth-like would not last long. It would be a transient state, because the tides from the Earth would be too big. It would either fall back or glue together into a smaller body. So it wouldn't stay there for very long, sadly.
What timescale are we talking about?
Depends what it's made of, depends how big the planet is and what the atmosphere is. It's uncertain. Probably millions of years-ish.
Okay, so we would have seen it if we had
and I'm seeing the question
at some point.
Yeah. Well, humans haven't been around for a long time, and we haven't recorded history for a long time. A million years ago, we weren't really recording history, so dubious. And yes, it would be more like a ring than a sphere, because there would still be an angle of collision. It would not come exactly to the center of the Earth. It will always graze a bit to the center. Just statistically, it won't be aimed directly at the center of the Earth. So because it misses slightly, there would be a preferred rotation. And if it collides with the moon, it's the same. It still has an angle of approach. And it will stay in that angle because it has no reason to change.
So to summarize what we have learned tonight is that basically we don't know enough currently to decide whether it would be possible, probable for life to exist, intelligent life at least, or even if there are enough Earth-like worlds out there.
Yeah. So contrary to what people may think, we only know about 20 Earth-like planets in the habitable zone, and none of them have a confirmed atmosphere.
Yeah, so and I honestly was one of the people that, because one of the arguments I usually hear is that, oh, we can't possibly be alone. The universe is so vast that, I mean, it would be extremely arrogant to believe that it's only us, or if not arrogant, it is just unlikely. Because even ignoring the fact that, oh, we're made of common stuff, but even if we were made of uncommon stuff, the universe is so vast that we can't even imagine it, it would be just illogical to assume that we're alone. The point is, we can't really say that for certain. The fact that something is likely doesn't mean it is actually true, right?
Yep.
At least from a scientific point of view, we can't. It's not enough. I mean, the fact that it is likely just because our brain and our common sense tells us that it is likely, and we can't even see how it couldn't be. That's just not a thing in science, right?
Yeah, we need statistics. We need something we can test and prove.
Because we all know that the human brain is quite fallible. We evolved to deduct and to draw conclusions from our immediate vicinity to survive. So we say, you know, we see a bush moving and we say, oh, there must be a dangerous beast. It is just wiser to assume there is a danger rather than assuming there isn't. Because if we assume that there isn't and there is, we're dead. If we assume there is and there is not, we are not dead. We're still alive. It's still safer, you know? So sometimes our brain makes us reach conclusions that, while they sound reasonable, they may be completely off. So it's one of these things. Ultimately, the answer is we don't know enough yet to have any sort of idea whether we are alone, whether there's a lot of people around there.
Whether the Earth was particularly hospitable or just normal or even inhospitable compared to other places for life to evolve.
There are theories, as we have discovered, but until we have better technology, better funding, and more time to actually explore those ideas, the only answer is we just can't know. We can hope for our preferred outcome, but from a scientific point of view, we just don't know.
But it's also getting a lot of funding, lots of things coming up in the future, and we're still finding new molecules in atmospheres of exoplanets. Every few months or so, there's a new first-time discovery of such and such molecule.
Yeah, exoplanets are a big thing lately.
It's moving fast, so keep watching.
There may be news, indeed. Hopefully, it will be quite interesting. Even if it's not intelligent, even just alien microbes would be something that we can actually say for certain that it doesn't come from us.
Mm-hmm.
That would be already something that we can work with. So it may. Do you think it will happen in our lifetime?
Yeah, I think so.
I do hope so.
Do you have any basis for that? Or just you wishing?
Just the new telescopes coming online. Once we start having actual pictures of exoplanets and we can make out things like clouds and stuff on the surface, it will really be a whole new era of information.
So even without seeing the actual dinosaurs on other planets, just by seeing clouds, we could...
Finding an alternative to Earth which would be habitable and which we could go to, that will definitely happen in our lifetime. That is quite close in the future, where we can find if any of these Earth-like planets actually have breathable atmospheres. The next 50 years at most, we will have one. And then humanity is kind of fine, because even if this Earth gets fucked, we can always jump in a spaceship.
And fuck the next one!
Yes!
Of course. That is the plan. Let's keep consuming worlds.
Nothing wrong with that if we're the only ones around.
Like a plague. And then, yeah. Like a virus spreading through the universe. Anyway, this has been Dangerous Cosmology for this week. I'm afraid that we are out of time. And we are also... Yes, if you want, you can. By yourself. But no, sorry. We just broke the 2 hours mark as usual.
I'm sorry, I'm actually too tired.
Yeah, and let's remember that our doctor here is really doing what she can. Yeah, so I think she deserves some proper sleep now. Indeed. But we will be back next week. We don't have a topic yet, but I'm sure that we will gather some suggestions. If you have any topic you would like to discuss during our show, feel free to drop a line on the Discord server of Distant Radio, and we will make sure to answer the questions that you have and talk about the topics that you're interested into. And as Shoba mentioned earlier, if you have questions that were not answered today or any other day, just drop her a line on Discord. As said, she's quite busy these days. She may not answer quickly, but she will answer, right?
Yep, I haven't missed a single one yet.
Good.
I'm all caught up.
So make sure to use that chance. Thank you very much for listening in, guys.
Yeah, thank you.
And as usual, I will see you next week. Thank you, Michael, for handling the technical side of things.
Yeah.
Thank you, Michael.
Before I forget it, don't forget to tune back in tomorrow at 7 p.m. Where we will be interviewing Turgeon Starstone, and yeah, this will be the real first interview completely in character. So be prepared for some entertaining roleplay.
Wait, are you for real?
Yeah.
I can actually roleplay. Okay,
I can roleplay if you are there. Nagi and I doing the interview, the main part of it.
I may pop in. I'll see if I can.
Yeah, sure.
All right. Thank you again, guys. This interview will be uploaded as usual.
Yeah, I think by 12 tomorrow.
If you missed the start, or if you want to re-listen to some parts,
yeah,
just go to the usual address, and
well,
you
I will post it in the announcements, of course, and stuff like that. So keep an eye on the announcements channel. If you have it muted, your own loss. Well,
cool.
anyway, thank you for listening.
If you haven't, if you haven't reached Sage yet, make sure to do it, because if it is your first time, it is a sight to behold. It is the first time for me, and it was quite impressive. So
I'm making my way there slowly.
Yeah, I know that you're slow. We know.
Anyway, yeah.
You'll get there before me, I'm sure.
Have a good night, guys, everyone.
Yeah.
I'll see you next week.
Exactly. Goodbye.
Bye.